everyone. I welcome you all in this new video. Let's come to the point. In this video, we are discussing vertical circular motion. It can be also written as VCM. It is come under the section like point mass. Usually we consider whichever object that is performing a vertical circular motion, that is a motion along a vertical circle, or the motion of the object along the circle which is in a vertical plane. That is known as a vertical circular motion, and that object we are considering as a point mass. So here is the discussion about the point mass undergoing a vertical circular motion under gravity. For this, we are considering that the object is performing this vertical circular motion in anti-clockwise sense. So that can be written, that can be shown on the diagram as I have drawn it already. Point A represents uppermost point. On that vertical circle. Point B represents lowermost point. And point C represent midway position. Midway position. Here we are considering, let that object or the point mass has mass m. So m represents mass of the object. Obviously, mg represent weight of the object. Weight of the object. And you all know that weight always acts in vertically downward direction. So at position B, which is a lowermost position, this is shown, this arrow represents the weight mg. Here, this arrow at uppermost position, this arrow represents the weight mg. Weight always acts in vertically downward direction. And if we consider a midway position, this is the arrow which represents the weight of the object. So at any position, if you find or object is located, its weight always acts in vertically downward direction. Now here we are considering that the object is tied to the string. So the object of mass m is tied to the string. The length of the string is now radius r. Since we whirled that string in a vertical circle of radius r, so here what it comes, that L is equal to r is equal to radius of vertical circle, or simply we can write it circle, radius of the circle. So as the object is whirled in a vertical circle in anti-clockwise direction, then as it is tied with the string, the force of tension or the tension force gets developed along the string towards the center. You just assume that we are holding that string in our hand, and to the free end of the string like this, a point mass is connected and we are whirling it in a vertical circle like this. So the tension gets developed in the string, and at different position, just as shown on this figure, this TB represent tension developed in the string at lowermost position. If I write for this arrow, at position A, which is the uppermost position, TA represents tension developed in the string when the object reaches that highest position. And let's write that TA, tension in the string, at position A. At position A. What is TB? TB represents the same thing but at position B. So TB is tension in the string at position B. So looking to the figure, what we observe, TA and weight mg at position A both are in the same direction along the string but towards the center. And when that object reaches to the position B, weight mg is in downward direction, but the tension in the string now is in vertically upward direction. Our interest in this topic is to derive the expression or to find the expression for speeds of the object at these three different positions. Which are these three different positions? Position A, which we have represented at the uppermost position. Position B, which we have said at the lowermost position. And position C is the midway position. We want to find out the speeds of the object which is performing a vertical circular motion at these three different positions. So let's start finding out that. First one, speed of the object at position A. This is according to the figure, but how we know this actually? What is the meaning of this? Speed acquired by the object, speed acquired by the object when it reaches the highest position or the uppermost position. When it reaches the uppermost position on vertical circle. On vertical circle. Yes. So let's derive this part. Now, if I show you the diagram again, just to have a quick look, see. When it reaches the position A, let us represent the speed acquired by that object by VA. Now, in this position, TA, which is a tension developed along the string, and the weight mg, both are in same direction. Both are acting along the radius, means along the string and towards the center. So the resultant of this is quite acting or providing the necessary centripetal force. So this can be written in equation form as below. See. At position A, at position A, tension TA and weight mg both are acting along the radius and towards the center. And towards the center. Hence, the resultant of these two will provide the necessary centripetal force. Let's write this. Resultant of these two will provide the necessary centripetal force. necessary centripetal force. This can be written in equation form as below, like this. TA, which is a tension at position A, plus mg is equal to necessary centripetal force. We know already the formula. It is mv square by r. Now this is v representing the speed at position A. So mva square by r. Let's write down about va. Va is what? Va is speed of the object at uppermost position, that is position A. A. Okay. Now, the criteria is the minimum possible speed. See, when the object is performing, instead of scrolling, I am drawing that circle over here again, just representing the circle. So this is what we have shown. This is the position A. Here, as we have considered, the particle, the object, the point mass is performing vertical circular motion in anti-clockwise sense. So at position A, this is the direction of speed, or this is the direction of velocity VA. And this is the lowermost position which we have represented at point B, and this will be the direction of velocity VB, or speed at position B. This is the center and this is R. Now, to continue, as the motion is under gravity, when the object reaches the position A, its speed goes on decreasing as it is moving against the gravity. Against the gravity. So speed VA will go on, or speed will decrease, speed will decrease, and when it reaches the highest point, the uppermost point at that on that vertical circle, this VA would be the minimum possible speed it has acquired just to continue its motion, its vertical circular motion. So for this, when it reaches the minimum speed, let us say that the tension developed in the string would be 0. So VA is the minimum possible speed. Minimum possible speed. Just to keep continuing that vertical circular motion. With this criteria, let us assume TA is equal to 0. Now, if we just call this equation as equation 1, let's number this equation. This is equation 1. Therefore, with this TA to be 0, what we get if we use this in equation 1, using this in equation 1, we get see, if I substitute in place of TA, it look like 0 plus mg, which is mva square by r. Don't forget this suffix a. Many students forget to write that, and it would get confusing about which position you are finding out the speed. So solving further, here what we have, mg is equal to mva square by r. As m represents mass of the object, the same object, about the same object we are talking, so m cancel out, and what we have, rg is equal to va square, and this gives us the required answer for va, That is, taking the square root on both sides, we get VA is equal to under root RG. And this is the necessary formula to find the speed of the object at highest position or at the uppermost position on the vertical circle. So this is very much important, and what we have assumed that this is tension. When that particle, when that object reaches the highest position, tension developed will be the minimum. And what is the minimum possible value? That could be 0. It won't, but that we are assuming TA is 0. So VA is under root RG is the speed it should acquire just to keep continuing the motion along the vertical circle. Okay, so let's call this equation as equation 2. Now, the second part of this derivation of this article, you can say, is to find the speed at position B. Speed of object which is performing, of course, a vertical circular motion at position B, which is a lowermost position, which is a lowermost position. Sorry, lowermost position. Yeah. Now for this, let's see the diagram again. Let's see the diagram again. That just help us to recall back how we have drawn that diagram. See this? Yes, here it is. Now, if B is the lowermost position, VB is the speed acquired by that object when it comes to the position B. Here at this position, as I said, or we already know, weight of the object is acting vertically downward, but now tension is always along the string. That is, it is acting along the radius and towards the center of that vertical circle. So TB, that is a tension, and weight, both are in opposite direction. So for this position, what equation we can write, which is balancing. Now the resultant of these two is providing the necessary centripetal force to keep the object continue its motion or to continue its vertical circular motion like this. So let's write that equation here. In detail we will write so that it will give you a quick review what is happening at position B. And this kind of description you can write in your answers when you are attempting different kind of exam, of course, theory exam. So let's write about this. When the object, when the object reaches position B, from figure we know, that tension developed in the string, that is TB, developed in the string that we have represented by symbol TB, and weight of the object, that is mg, are acting along the same line but in opposite direction. along the same line, but in opposite direction. So in equation form, therefore, we can, or let's write this also, the resultant of these two, the resultant, of course, force, the resultant force of these two forces, gives the necessary centripetal force, necessary centripetal force for what? For continuing vertical circular motion. So this can be written as TB, which is a tension in the string, minus mg. Why minus? Because both these forces are acting in opposite direction, and the resultant of these two is now providing that object the necessary centripetal force, which is written as mvb square by r. Here, what that vb represent? Vb is the speed of the object, speed of the object at lowermost position, at lowermost position. Okay, let us call this equation as equation 3. Whenever we need it, we can just use the number of that equation, so we don't have to write the equations again and again in the answer. Now, our task is to find this VB, the speed acquired by the object when it reaches that lowermost position. Okay, so here I am opening the new page. For finding out the speed of the object at lowermost position, what we are using is the law of conservation of energy. So to find the speed of the object at lowermost position, that is point B, lowermost position B, let us use principle of conservation of energy. Principle of conservation of energy. Now, to use this principle of conservation of energy, we are considering two positions. Which two positions? Just to have a reference, I am drawing that rough circle over here again. See, this is a vertical circle we are considering just to study the motion of the object along this circle, or just to find out the speeds at different positions. And we have considered position A as a highest position, position B as a lowest position. This is the direction of velocity at B. This is the direction of velocity at E. Now, this point represent O. O is the center of that vertical circle. Now, as this is the highest position and this one is the lowest position, what we have, according to the principle of conservation of energy, Total energy from this principle, total energy at position B is equal to total energy at position A. Total energy at position A. So in a short form way, we can just write it like TE at B is equal to TE at A. And we all know total energy is nothing but the sum of kinetic energy and potential energy of the object at those respective positions. So total energy is what? Is for B, it is a kinetic energy possessed by the object at position B plus potential energy possessed by the same object at same position B, which is now according to what? Principle of conservation of energy is the sum of kinetic energy of the same object which is performing vertical circular motion at position A plus potential energy of the same object when it reaches the position A. Now, we know the formula for kinetic energy. Kinetic energy is half m. Now at position B, so we will write half m vb square plus, here we write the general formula is mgh. So just to say about the position, we write here mgh suffix b, which is equal to half m va square plus m G H A. What are HB and HA representing? Here, HB is equal to 0 and, or let's give the reason here itself, since to find potential energy, we have considered position B as our reference point. We have considered position B as our reference point. Okay, so if we measure everything, the reference point is what? From 0, the 0 point. So from there itself, we are starting measuring the height. Now HB is what? Height of the object above the reference line. Now itself it is at the position B. So HB is equal to 0. And what about A? When it reaches A, it has acquired the vertical height which is equal to R plus R. So which is 2R, right? Which is 2R. So let's write that. And HA is equal to 2R. Now substitute this in above equation. Which one? This one. So whenever we are substituting any values in the equation, it is preferable to give, to allot some number to that equation. So we have come up to the equation number 3. So let's assign equation number 4 to this one. Yes. So this is our equation 4. Substituting the values of HB and HA. Substituting the values of HB and HA in equation 4. What we get? We get half mvb square plus mghb is now 0, which is equal to half mva square plus mg here 2r. Now, if you observe closely the equation, m appears everywhere in every term on both sides of the equation. So it cancel out. So what it remains here, half vb square plus 0, g into 0 will give you 0, which is equal to half va square plus 2gr, or we can write down 2rg. So same thing can be written as half vb square is equal to half va square plus 2rg. Now, if we take the LCM on RHS, what we have here, half VB square is equal to VA square plus 4RG upon 2. Now we know VA is under root RG. Since VA is under root RG, therefore VA square is RG. Let us substitute that over here and we have therefore VB square upon 2 is equal to RG. We have substituted the value of VA over here or VA square over here plus 4RG upon 2. This 2 cancel out. What we have is VB square is equal to 5RG. As we want the expression, the value, the formula for VB, that is speed of the object which is performing vertical circular motion. Now at lower position, it will have the speed which is given by 5rg. That means we have taken the square root on both sides. So this is the formula for speed of the object at lowermost position. Let's write this one also. These conclusive statements are much more important just to have a good impression in from the point of view of examiner. Okay, so here let's write this. This expression gives the speed of the object performing vertical circular motion. For that, I am using the abbreviation as VCM at lowermost position B. Lowermost position B. Okay. The same criteria, the same principle can be used to find out the speed of the object at midway position that we have shown on the figure initially that we have seen, that is by point C. So the third and last part of this topic is to find speed of the object when it reaches midway position. When it reaches midway position, that is point C. Point C. For our reference, instead of Going back to that previous page, here again a rough figure I am drawing just to have a look of midway position and the lowermost position and the highest position. So if this line represent the lowermost and uppermost and this point, let's show the points also. The positions mean, A is the highest, B is the lowest, and C is a midway position. Yeah. Now, when it reaches, when the object while performing VCM, when it reaches that midway position, this is the direction of the speed of the velocity VC. And if I consider B point, which is the lowermost point, again here point B we are considering as a reference point. So VB is the speed acquired by the object at position B. So using the principle of conservation for what? To find the speed at position C. Using the principle of conservation of energy. Conservation of energy. For positions B and C. Because to use that principle, we always need 2 points and position C. We have. How do we write? We know now principle of conservation of energy. Total energy at position B is equal to total energy at position C. So let's write that. We have total energy at position B is equal to total energy at position C. Total energy, of course, possessed by that object which is performing vertical circular motion. So total energy at position C. So again, in a short form way, it is TE at B, which is equal to TE at A. Sorry, TE at C. B and C we are considering. Total energy is the sum of kinetic energy. So kinetic energy at B and potential energy. So it is Ke at B and P at B, which is equal to Ke at C plus Pe at C. Now, if we observe the figure, as here we are considering the point B as a reference line. Then the vertical height, the vertical distance between position B and position C is equal to the radius R of the vertical circle. So here, let us write that Ke is represented by formula half m VB square plus mghb, which is equal to half mvc square plus mghc. hb and hc represents the height of the object from the reference line. So let's write over here. Here we are taking point B as a reference point, as a reference point. And therefore, HB is equal to 0 and HC is equal to R. Substituting this Now, let's, as I said earlier, let's call this equation as equation 6. Equation 6. So, substituting the values of HB and HC. Substituting the values of HB and HC in equation 6. We get half mVb square plus mghb is now 0 is equal to half mvc square plus mg, as we know hc is r. Again, in this equation also, on both sides of the equation, m, which is mass of the object, appears in every term on both sides of the equation. So it cancel out, and what we get, what it remains is half VB square. The second term, as you see, it gives us 0, which is equal to half VC square plus RG. Here I am opening the new page. So what we get, what it remains is half VB square is equal to half VC square plus RG. Let's check that one. Yeah. So in a nice format, it is written as VB square by 2, which is equal to VC square by 2 plus RG. Now, if we take the LCM again on the right hand side, just to make equality, plus 2RG by 2. What it gives us like this. Now 2 appear on both sides, it cancel out, and what it remains is VB square is equal to VC square plus 2RG. Now here we have already found out the speed of the object at position B. Okay, so, and that is nothing but under root 5RG. Since VB is equal to under root 5RG, therefore VB square is equal to 5RG, squaring both sides. What it gives us, 5RG is equal to VC square plus 2RG. Now, just rearrange the equation, 5RG minus 2RG, which is VC square. So it gives us 3RG is equal to VC square. Our interest is to find again the speed and not the square. So taking the square root on both sides, we have VC is equal to under root 3RG. This equation represents the speed acquired by the particle, by the object, by the point mass, whatever you call it, when it reaches the midway position along that vertical circle. So let's write down this. This equation gives speed acquired by that object when it reaches the midway position, point C, of course represented by point C, while performing vertical circular motion while performing vertical circular motion. Yes. So today we have seen the expressions or the derivations, or how we can derive the expressions for speeds at different three positions: uppermost position or highest position, lowermost position or a bottom position, and the midway position. So let's summarize that once again. Finally, of course, here at this statement, here our answer for the given derivation is ending. So let me mark that. And to have a summary of these three formulae again, or to just recall these three formulae: VA is speed at highest position, is given by the formula we have derived is under root RG. VB is equal to speed at lowermost position, and is given by under root 5RG. And of course, the last VC is speed at midway position. These three we have seen today. Midway position, which is under root 3RG. So using that principle of conservation of energy, you can figure out the position or the speeds at different position. But according to the scope of syllabus for 12th standard HSC board physics syllabus, we require only these three positions: VA, VB, VC, highest, lowest, and midway position. So here I am stopping sharing this screen. Yes. So here today's topic we have discussed in a very simplest and nice way. If you like this representation, if you like this explanation, do follow my YouTube channel, Knowledge Lane, the Physics Classroom. Here, what I have started with, like I'm giving a revision kind of things, a summary of different topics, one topic selected in every video. So there is no need to see or to watch for a longer videos. You can pick up any of the topic and you can revise that at the time of exam or in between also. This would be very much helpful. I am very much sure about this. So do like, or if you like, do share this and subscribe my YouTube channel, Knowledge Lane, the Physics Classroom. See you soon in the next video. Bye bye.